Synnefo is a complete open-source cloud stack written in Python that provides compute, network, image, volume and storage services, similar to the ones offered by AWS. Synnefo manages multiple Google Ganeti clusters at the backend that handle low-level VM operations, and uses Archipelago to unify cloud storage. To boost third-party compatibility, Synnefo exposes the OpenStack APIs to users. Synnefo is being developed by GRNET, Greek Research and Technology Network, and is powering two of its public cloud services. The okeanos service, which is aimed towards the Greek academic community, and the okeanos global service, which is open for all members of the GÉANT network. History. In November 1991, in an effort to provide advanced cloud services for the Greek academic and research community, GRNET decides to launch a cloud storage service similar to Amazon's S3, called Pythos. The project is outsourced and opens for public beta to the members of the Greek academic and research community in May 2009. In June 2010, GRNET decides the next step in this course to create a complete AWS-like cloud service, compute, network, volume, image, storage. This service, called okeanos, aims to provide the Greek academic and research community with access to a virtualized infrastructure that various projects can take advantage of, e.g., experiments, simulations and labs. Given the non-ephemeral nature of the resources that the service provides, the need arises for persistent cloud servers. In search for a solution, in October 2010, GRNET decides to base the service on Google Ganeti and to design and implement all missing parts in-house. In May 2011, the older Pythos service is rewritten from scratch in-house, with the intention of being integrated to okeanos as its storage service. Moreover, the new Pythos adds support for Dropbox-like syncing. In July 2011, okeanos reaches its public alpha stage. This version, v0.5.2.1, includes the identity, compute, network and a primitive image service. The alpha release of the new, rewritten Pythos follows shortly after. In November 2011, it is marketed as Pythos Plus and the old Pythos remains as a separate service. The new Pythos Plus, though not integrated to okeanos yet, provides syncing and sharing capabilities for files, as well as native syncing clients for Mac OS X, iPhone, iPad and Windows. In March 2012, okeanos enters the public Alpha 2 phase. This version, v0.9, includes a complete integration of the new Pythos as part of okeanos and now acts as the unified store for images and files. Around this point, in April 2012, the okeanos team decides to refer to the whole software stack as Synnefo and starts writing the first version of the Synnefo documentation. In December 2012, due to interest from other parties to the Synnefo stack, GRNET decides to conceptually separate the okeanos and Synnefo projects. Synnefo starts to become a branding-neutral IaaS cloud computing software, while okeanos becomes its real-world application, an IaaS for the Greek academic and research community. In April 2013, a new Synnefo version, v0.13, gets released after a huge cleanup and code refactoring. All separate components are merged under the single Synnefo repository. This is the first release as a unified project, containing all parts, compute, network, volume, image, storage. In June 2013, Synnefo v0.14 gets released. Since this version, Synnefo is branding neutral. All remaining ~okeanos references are removed. It also gets a branding mechanism in the corresponding documentation, so that others can adapt it to their branding identity. Overview. Synnefo has been designed to be deployed in any environment. Components. Synnefo is modular in nature and consists of the following components. Astarcos. Identity, account services. Astarcos is the identity management component which provides a common user base to the rest of Synnefo. Astarcos handles user creation, user groups, resource accounting, quotas, projects, and issues authentication tokens used across the infrastructure. It supports multiple authentication methods. Pithos. File, object storage services. Pithos is the object, file storage component of Synnefo. Users upload files on Pithos using either the web UI, the command line client, or native syncing clients. It is a thin layer mapping user files to content addressable blocks which are then stored on a storage backend. Files are split in blocks of fixed size, which are hashed independently to create a unique identifier for each block. So each file is represented by a sequence of block names, a hash map. This way, Pithos provides deduplication of file data. Blocks shared among files are only stored once. The current implementation uses 4 MB blocks hashed with SHA-256. Content-based addressing also enables efficient two-way file syncing that can be used by all Pithos clients, e.g., the Kamaki command line client to the native Windows, Mac OS clients. Whenever someone wishes to upload an updated version of a file, the client hashes all blocks of the file and then requests the server to create a new version for this block sequence. The server will return an error reply with a list of the missing blocks. The client may then upload each block one by one, and retry file creation. Similarly, whenever a file has been changed on the server, the client can ask for its list of blocks and only download the modified ones. Pithos runs at the cloud layer and exposes the OpenStack Object Storage API to the outside world, with custom extensions for syncing. Any client speaking to OpenStack Swift can also be used to store objects in a Pithos deployment. The process of mapping user files to hashed objects is independent from the actual storage backend, which is selectable by the administrator using pluggable drivers. Currently, Pithos has drivers for 2 storage backends. Files on a shared file system, e.g., NFS, Luster, GPFS or GlusterFS. Objects on a CEPH, RADOS cluster. Whatever the storage backend, it is responsible for storing objects reliably, without any connection to the cloud APIs or to the hashing operations. Cyclades. Compute, network, image, volume services. Cyclades is the Synnefo component that implements the compute, network, image and volume services. It exposes the associated OpenStack REST APIs, OpenStack Compute, Network, GÉANT and soon also Cinder. Cyclades is the part which manages multiple GRNET clusters at the backend. Cyclades issues commands to a GRNET cluster using GRNET's remote API. Our API. The administrator can expand the infrastructure dynamically by adding new GRNET clusters to reach data center scale. Cyclades knows nothing about low-level VM management operations, e.g., handling of VM creations, migrations among physical nodes, and handling of node downtimes. The design and implementation of the end-user API is orthogonal to VM handling at the backend. There are 2 distinct, asynchronous paths in the interaction between Synnefo and GRNET. The effect path is activated in response to a user request. Cyclades issues VM control commands to GRNET over our API. The update path is triggered whenever the state of a VM changes, due to Synnefo or administrator-initiated actions happening at the GRNET level. In the update path, we monitor GRNET's job queue to produce notifications to the rest of the Synnefo infrastructure. Over a message queue, users have full control over their VMs. They can create new ones, start them, shut down, reboot, and destroy them. For the configuration of their VMs, they can select number of CPUs, size of RAM and system disk, an operating system from predefined images including popular Linux distro, Debian, Ubuntu, CentOS, Fedora, Gentoo, Arch Linux, OpenSUSE, MS Windows Server 2008 R2 and 2012, as well as FreeBSD. The REST API for VM management, being OpenStack compatible, can interoperate with third-party tools and client libraries. The Cyclades UI is written in JavaScript, jQuery, and runs entirely on the client side for maximum responsiveness. It is just another API client. All UI operations happen with asynchronous calls over the API. The networking functionality includes dual IPv4, IPv6 connectivity for each VM. Easy platform-provided firewalling either through an array of pre-configured firewall profiles, or through a roll your own firewall inside the VM. Users may create multiple private virtual L2 networks, so that they construct arbitrary network topology, e.g., to deploy VMs in multi-tier configurations. The networking functionality is exported all the way from the backend to the API and the UI. See also OpenStack, GANET, Zen, KVM, official website, _okeanos website, _okeanos global website.